All right, we'll be starting here shortly. Just getting the last little bit settled down and getting set up. Forward to continuing where we left off on Sunday and see where we come out. Did manage to do a little upgrade to the setup. Got a new microphone, so that should be good. Hopefully the audio is good. Definitely let me know if it's too low, too high, or whatever. We did a little check beforehand and it seemed to be all right, so I think we're good to go. I wanted to kind of recap from where we left off after the weekend, which was a literal marathon of streaming. You can thank the weather for that or whatever, but it was definitely a lot of fun, and I was able to get all the videos up on YouTube. I did manage to find out that apparently everybody with Amazon Prime has Twitch Prime, so the videos will stay on Twitch for 60 days before they roll off, so you can see them in either place. I tend to like Twitch for real-time streaming, but for everything else, they seem to be showing up on YouTube eventually as well. I know there's difficulties in accessing YouTube in certain parts of the world right now because of the global bandwidth use of everybody being at home, but hopefully they're able to figure that out and they're watchable. I did make a couple of tweaks. I did increase my font size 1 point, so hopefully it should be a little easier to read the text when you're sitting on the sofa looking at it on your big screen TV. There was one question about the video format. It is 1080p. I do size my screen to a 1080p window, so it's a subset of my 4K monitor, but you're getting a full 1080p view of the editor and things like that. So not much else to cover on the intros. Some of the things that I want to cover tonight, I kind of made a little notes of when I wanted to go since I was pretty off the cuff on the weekend. I think where we left off last time is we had created a Saga to track allocations in the inventory service, and we had added Quartz scheduling to be able to schedule an automatic release of the hold on product from allocation. So I thought tonight we could add a new payment activity that's going to potentially fail so that the routing slip will fail and cause the compensation to execute, which would release that allocation. When the Saga releases that hold, that'll show us how we can actually unschedule a message from a Saga. And then I thought we'd talk about routing slip subscriptions and how to create your own messages that get sent when routing slip activities or the routing slip itself completes. And then if we have time and I'm still up for it, we might add the out-of-stock response for the routing slip so that the allocation activity itself can also fail. So I figure now we can get started at it and get going. I have all the projects opened right where we left off on the last episode. Just to kind of refresh, we had the warehouse solution folder where we have our virtual warehouse. That includes a separate console service that has its own contracts and its own sagas for allocating and managing inventory. We have the API endpoints, which we've added Swagger to so that we can actually go out and test and get status of orders and things like that to find out if our orders have been satisfied, fulfilled, whatever. I believe if we just do a get, we can check and see. Sure enough, our order's in the accepted state, so that was the last GUID that we had specified for our order ID. And we have our consoles up and running. We have the web service itself. We have the backing service that supports all of the ordering business domain. We have the warehouse service, which includes all of the warehouse activity, the allocations. We can even see that my allocation was removed based on that timeout because the allocation hold expired. And then we have our scheduling service, which is that sample Quartz taken straight from the GitHub MassTransit organization's repository that's doing our scheduling for us. It's talking to SQL. If we were to actually go out here and look, we can see that I have a whole bunch of Docker containers running right now. I have RabbitMQ running in a container. I have Redis, I have MongoDB, and I have SQL Server. So basically everything I could possibly run is all running in separate containers. So let's jump into it. Let's get up into Rider. Let's go look at our routing slip activity that we had for the allocate inventory. We can see that that's up on the screen here. The response for the allocated inventory, we mark that allocation ID. One of the things that we want to do now is we actually want to make it so that we can fault this routing slip so we can test that compensation. And one of the ways I thought we'd do that is we would just create a second activity, one that would account for actually simulating a payment. Like once we've determined what items can be allocated, what's the total cost of the order? So we'll go ahead and create a new activity. That's going to be the, we'll just call it the payment activity. Why not? No reason to overcomplicate it. Payment activity, if you remember when we have activities in this one, because it is a payment, we would be doing like an authorization or a billing on it. So I think we want to have both arguments and a compensation. So we'll create our arguments. We'll just call these the payment arguments. And we'll get the order ID because we want to be able to reference that. We'll put a decimal for an amount. And we'll put, what else would we put? I don't know. We'll put a card number. Sure, why not? We'll just put sort of something that we can pass data to make it fail if we pass it a certain card number. Something we typically do in our systems for synthetic transactions is we have card numbers that trigger certain behaviors in the activities so that they can be tested without, causing any failures on regular systems. So we have our payment arguments now. Let's just, let's say for the payment log that we're going to have, we'll have an authorization code or something that we can all relate to when you swipe a credit card. And then we'll put these on the activity. So we will have the payment arguments and the payment log. This will implement our two members, because remember each activity has an execute and a compensate. So for our execute for our payment, let's first check and see if we're that test identifier. So let's do that card number equals context.arguments.card number. Let's go ahead and check if that happens to be null. Albert, welcome to the chat. Okay, so we're going to check if that card number is null, and because we want to be able to simulate a failure, we're going to say if card number starts with 5999, we'll say that that will be our example case where we want to crash a horrible death. And in this case, for an activity to fail, it just has to throw an exception. So in this case, we're going to just do something, I don't even know what makes a good one. Let's just pick a random one. Invalid operation exception. The card number was invalid. And that'll just give us an exception that we can actually fault the routing slip with, so we'll be able to test that. And we aren't going to actually process a payment. I mean, we could do a task.delay of a little bit just for fun. And then we're going to return context.completed. We will pass the authorization code equals. We're just going to hard code that for now. There isn't any reason to get too ridiculous about it. Compensate, we aren't going to really do anything right now for compensation. We're just going to say that we compensated. I guess I could have task from resulted that, but why not? Here, we'll put a little delay in so it's fun. And by little, I mean really little delay. So we'll move our arguments over here, and this is going to be our second activity, and this is the payment activity. Now, currently our activity, currently our routing slip, we have a consumer that creates that, and that's our fulfill order consumer. The fulfill order consumer currently adds that activity for allocate inventory. So let's add the next activity. In this case is going to be the payment activity. And the name that will get assigned for this automatically is payment_execute. We only have to know the execute address for activities. We don't have to know the compensate address. And when Conductor gets a little smarter, it will actually look at the discovered activity names, and actually the plan for that is to have a routing slip builder that will actually validate the activities and automatically populate the URLs for you. So that should be cool when that gets ready. That's a ways off though, so don't ask, is it there yet? Because it isn't. To pass this through, the question in the chat is that by convention? Yeah, so because I'm using configure endpoints, the default behavior is to take the activity name, strip off the word activity, and then case it the way you specify. I've specified kebab case, but since this is just one word payment, it'll be payment_execute. I thought that it would be payment-execute, and I think I wanted to be clever and do that with the kebab case formatter, but then I thought I would probably break somebody and that wouldn't be fun. So rather than break somebody to make it look pretty, I decided to leave it the way it was, just so it doesn't mess people up. So the card number I want to actually get out of the order fulfillment, and I don't think I have that in there right now. In fact, I don't think I have anything as far as like tracking a card number through the system. So in theory, I could go and put this in every single contract all the way back up to add the card number. Or I can just fake it. I don't know. Let's put a card number in here. I don't know. That seems weird. I don't think it belongs there. I'm just going to fake it for now because I don't want to slow us down too much. For now, I'm just going to say card's going to be 4,000 because we can just come change this, and as annoying as that'll be, we'll come change it for now. I think we also have to have an amount, and I'm just going to call it 99.95. Because the order ID is already added to the variables by the routing slip builder, both activities will get it because it's pulled from the variables if it isn't found in the explicit activity arguments. We will probably have to eventually come back and put the card number in there, but we're going to let it go for now, so we'll be all right. The first thing we want to do is just verify that it actually runs successfully, and then we'll go in and change it and put the card number to something bad. Okay. Right, so we went back to our consumer. Our consumer is adding the additional activity. And we should just be able to execute this. All right, so let's see. Let's save that out. Because we've modified the only service we've modified is the order processing service. We haven't modified the warehouse any, so we don't need to restart either of those. So we'll just restart, and we'll basically restart as building and running versus actually deploying it to a container and actually running in a container instance, which we might get to in a later episode. That would be fun. Now we'll go back to the website. We will have to create a new order ID because it's time for a new order. We'll post the new order ID in here. We'll execute that. We have the order ID there with the proper customer number. We get the order, we should see that it's submitted. We patch the order. We should see that it's patched. Well, it doesn't really show us anything, but when we refresh the status, we should see that it's accepted. And when we go out to the service code, we can see that the warehouse is still doing its thing over there, but it looks like it finished. We have the routing slip activity completed for the payment activity. Okay, so if you remember, we created a consumer that captures these activities, and you can see that the routing slip activity completed for allocate inventory, the routing slip activity completed for the payment activity, and the actual routing slip completed. So by adding that extra activity, it did succeed. It ran both activities, it ran them in order, and the rest of the backend processing didn't change because we didn't change any of that behavior there. So good, that's awesome. Now, let's change it so that that actually fails and see what happens there. So we're going to come back in here and we're going to change the card number to 5999 1 2 3 4 5 6 7 8 9 10 11 12. Cool. A little bit hard-coded, but it's what we're going to do today. So we're going to go back to the website. We're going to go create another order ID. I should have a service to just create me an order ID, but then it would be breaking my own rules, so we're not going to do that. So we will execute our order creation. We will go straight down and patch it so that we get it. And now we're going to go look out here. And we see a couple of different things here. We see that where was it at? The allocate activity, the allocate inventory succeeded. We did a receive. We have an allocate inventory execute. It was done. We got to the next one. Now we have a routing slip activity faulted, and we weren't tracking that in our event auditor, so that's no good. We just don't see it. But here you can see we actually did a send to allocate inventory compensate, which is the compensate address for the allocate inventory, which then payment execute completes, then the compensate activity executes. At this point, we're declaring the exchange name allocation release requested. We call send, so we published that allocation release requested event as part of the compensation for the allocation activity. The routing slip activity compensated event was published. The routing slip faulted event was published. And that finished there. Now let's go back here to our warehouse service. It looks like we created, added, we allocated the inventory, the allocation state was updated, and the saga was used by the allocation hold duration expired. So it looks like it's still, so it looks like it got the allocation released from the timer event. And what we really want to happen there is we want to have the event that we published to the warehouse saying that the order, the transaction faulted and we compensated that allocation. We want to release that hold without waiting for the timer. So we're going to stop the warehouse service and let's go look at the warehouse now. So we have the two activities. Within our warehouse, we have the state machine that keeps track of the allocation. So the allocation state machine currently only looks at the allocation created event or the allocation hold duration expired event. We never actually put that event in there despite actually defining it. Question in the chat is, what was that little window in Rider? Which little window? I have no idea. I have no idea which little window it would have been. Do you remember what it looked like? I have no idea. I'll try to catch it next time, but I don't know what that would have been. So I'm going to add the event that I published for the allocation release requested. And what I want to do with this event is I am going to need to correlate it because it has the allocation ID. And I need to add an event handler for it. So if we are in an allocated state, we want to add when release requested let's do the same thing we would do here, act like we were going to unallocate it. We will finalize because we want to go allocation release request granted. One of the questions in the chat is, what is schedule in a state machine? So schedule, we went over that in the previous episode. That was where we actually can create a scheduled event, a place to store the token, and then call the method .schedule to actually schedule a future event for this Saga instance. So that handles the initialization, and that's how we're scheduling the automatic allocation hold release. So when that timer expires, it gets delivered to the hold expiration received event, and then causes it to go to the allocation was, and I'll change this to say automatically. I'll just say allocation expired, since that's really what we were doing there. So Quartz is not in Quartz. I mean, it's using Quartz in the background. It's just that's how state machines can coordinate scheduled events, whether that's using Quartz or whether it's using Azure Service Bus Scheduler. Either one, they can be used. So. Yeah, no worries. So now we have two handlers, one that handles the release requested and then one that handles the finalize. Okay, good. So now we're there. So we'll save that out. We'll go back and we'll restart our warehouse service. And we will go and get a GUID. Is this the window you were asking about? There's a menu option called Tools, Generate GUID. That's what that one is, if that's the one you were referring to. So we're going to go to our post order. We're going to post this in. We're going to hit execute. And then we're going to send a patch to accept the order. And then we're going to go look at our warehouse. And we can see our warehouse. We scheduled the message. The allocation was created. And then we received an allocation hold duration expired. Used, removed. Okay, so we didn't get our request for... We didn't get our requests at the state machine level, and I wonder why, because that's what we just added. We added the release requested. The event is the allocation release requested. Let's see what it's set up in RabbitMQ. Did we actually get a... queues? So within our allocation state, ooh, we did get an allocation state error. What is in the error queue? Let's go look at that message. Oh, that was our error from a long ago. That was one we got Sunday. We can forget about that one. 323, yeah, that was ages ago. We can delete that one. We don't need that message. Let's not let that confuse us. That was before we set up the Saga properly. So let's go back to our allocation state queue. And here we can look at the bindings to see what's allocated to there. So we have the release requested event. We bind that, so it's there. So why didn't we get it? Let's go look at our service and see if we actually published it. The routing slip faulted. The payment activity finished. This is where the logs come in really handy, so you can just go back and look and see everything that it sent. We did a send for the activity completed. We did a send for the routing slip activity faulted. We did a send to the compensate. We did a send to the allocation release requested. So we did request a release of the allocation. Or published, I should say. And then, so why didn't we get that over in the state machine? That's a good question. Correlate by message allocation ID. So we're correlating by allocation ID, which is going to create that ID for the state machine. I wonder if we have a timing issue. I wonder if we have a timing issue to where the being released before it's stored. So let's go look up here in the warehouse and see if we received any earlier messages. Allocation created. Consumer. I don't see one up there. Hold duration expired. That's where we scheduled the hold duration. So let's go look at the consumer that creates the allocation. They were storing it for 8 seconds. Let's make that like 15 seconds. And see if we're just too quick. And let's take, oh, the delay. Yeah, I bet we missed the message. Let's take that delay out and like really quickly do this. Well, no, because the delay was before we returned that, so it really wouldn't matter. Well, we'll take the delay anyway out because we don't want it to be sitting there forever. We'll go back and we'll run the warehouse again. Let's try this again. We will execute, create the order. We'll approve the order. Application create. Oh, look at this. Sure enough, we got the release requested before the saga was created. Yeah, look at that. That's one of the fun things about messaging is that things can happen out of order. And this is actually a good example because, I mean, I had to dig in and see that I was actually getting the event to release the allocation before I even had the allocation state created. So how could we handle that? Let's take a look, because this is something that will come up and you will find this because messages are never guaranteed to appear in order. So let's look at what we can do about this. So let's open this up a little bit. So with the allocation state machine, what's happening is we're getting the release requested before we're in the allocated state. So we have a couple of options because we don't want the allocation to be created after the fact if it's already been asked to be deleted. And this is another nice thing about the actual allocation ID being assigned up front, because it will all correlate together and I don't have to worry about it having not been allocated or having like a different ID generated. So let's create an additional handler here in the initially. Let's say that when I get a release requested, I am going to transition to released. And that's going to essentially create a new state called released that it's going to put my saga into if I receive that message first. And then I will create another one. Question in the chat, could you just self-delay the message? So could I delay the message? I could. I mean, I could say if I get a release requested, I could just throw it and say, you know what, send me this again in 5 seconds. I could do that it seems a little more complicated because then I have to go find that. And I don't really have an easy way to do that. I mean, I could just schedule it to myself, which would be kind of funny actually. But I think in this case, I just want to set myself into a state, because if the instance was missing, I could, I could do an on missing instance, and I could say, send me this again in a minute. And I mean, I wouldn't know how long. So Dom, welcome to the chat. I wouldn't know how long to delay it for. I mean, it could be that the message is backed up in a queue. I think it's more explicit to say during released, when allocation created, I'm just going to immediately do, at this point, I would actually go out and do my behavior for releasing the allocation. Basically, I could do the same thing like I'm doing here and just say allocation was already released. And then transition to, or then I would finalize and say, okay, that completes it, because I don't want to go back in state. I just want to say, hey, that's where I needed to be. That's where I'm now at. So now I'm done. Yeah, so that would do it. So now let's see what happens here. And I should say was already released. Okay, so now let's go start my warehouse back up. Bring the warehouse back online. Everybody back to work. We will create our GUID. Go back to our website. Create our order. Accept our order. And then watch our warehouse blow up. Ooh, yay. I like duplicate key errors. We are learning all the good things today. This is awesome. We are running into every problem you're going to have writing code with MassTransit. Look at this. I'm getting nasty errors about duplicate key exceptions and correlated errors. This is all fun stuff. So what happened? I accepted a message, and geez, within a split second, I got another message at the same time for the same Saga instance that has the same key. So Mongo, because I think I'm using Mongo here, is going to blow up and say, hey, I got a duplicate key error. It's not accepted in this. Now I got all this stuff confused. What's going on? I scheduled an expiration, but it didn't happen. I scheduled an event. The scheduled event happened, and now I don't know how to handle that either. I got like 3 different areas. And yes, we see this kind of stuff in production because there are capabilities in MassTransit that can fix this for you. So let's go back to our state machine, because this is where it gets fun. So if we look at my service and in the program CS where I'm configuring my bus, you can see that I'm using the configure endpoints. Configure endpoints automatically configures everything that I add, and the only thing I'm adding in this one is this state machine as well as those consumers. So all of this container configuration logic was created, I don't know, a while back, but it's really kind of handy because it makes it very clear. But since you're allowing the container to configure the endpoints, you've kind of lost the ability to fine-tune each receive endpoint. So what you do when you create a state machine or anything like this is you create another class next to it called, let's call this the allocate state machine definition. And so a definition file, in this case, it's going to be a Saga definition based off the state type. So it's the allocation state. And this allows us to do things like define how we want to handle messages within the endpoint. So we have a number of different values we can set here. We can set the name if we want to force a particular endpoint name. We could set the concurrent message limit if we only want to handle a certain number of messages at a time. And either of those 2 things can be set. We can also configure the Saga and the Saga messages for each one of the types received by the Saga. So this is where we would actually have access to control the receive endpoint. So I don't really need to put a concurrent message limit here. I could do something silly like 4 because I still want to be able to get 2 at a time so that I can cause the exception to happen. But I'm going to override the configure saga method, which is going to give me access to 2 things. It's going to give me the receive endpoint configurator, which is great because that's what we're going to modify. And it's going to give me the saga configurator, which lets me do things to the saga configuration. So MassTransit has 2 capabilities to deal with this lovely optimistic concurrency that we get with MongoDB. First of all, it's going to allow me to come in and say, I want to be able to retry those errors, because if I read that state from if we both went to the database and did not see an instance of that saga, we're both going to try to create it, and one of us is going to get a duplicate key error, which means I still have a message to process, but I need to process it after that other message completes and writes the saga to the database. So I want to be able to retry that, and I'm going to add that using endpoint configurator.useMessageRetry. And to configure that, I'm going to add I'm just going to say I'm going to do it with an interval. I'm going to retry up to 3 times every second. So it's going to wait a second, and then it will send the message again back through the pipeline, which will try to reload the saga. It does this entirely in memory. It still keeps the message locked on the broker. So doing something like 1000,30 saying you want to retry 1,000 times every 30 seconds is like, you would never do that. That would just be crazy. You would be much smarter to create some other way to handle retries that way. Because that's all going to just basically sit there and wait and block your message consumption pipeline for that thread. So we'll do a simple like 3 retry, and we'll even go to 500 milliseconds because we'll act like MongoDB is fast, but it's running in Docker, so let's just give it the benefit of the doubt. It is MongoDB. It may be web scale, but it's not quite Docker web scale. And so that's going to give us that retry capability. Now, the other issue that we saw in that log when we were watching it is we had 2 messages here. First we had the duplicate key issue, but then we had the fact that we had scheduled an expiration, but that instance was not there because we weren't in the correct state, because the state was in released. And what happened there is the first instance said, oh, I'm going to create it, I'm going to schedule this message, and then I'm going to go into my allocated state. But the release state had already been written to disk, so it got a duplicate key error, and it blew up, and it processed the message again. That failed, but the message being in the release state, the scheduled message was delivered, and it says, hey, I don't handle this in release. I don't know what to do with this. So we ended up with messages that were sent out of the saga for a saga state that never became itself. And I did a blog post a couple months ago about how the outbox in MassTransit works. And that's how we're going to solve this, is we're going to add the in-memory outbox. And what that's going to do is hold those messages until the persistence part of the transaction is completed and then send them. So in this case, what will happen is we will then send the messages. We will then schedule the release upon successful completion, but we won't send it if there's a failure. Now, there's one other thing we need to think about when we do that, and that is we need to expect that an allocation created message could be received when I'm in the allocated state. And the reason for that would be, if you think about the flow of a message, the message is read from the broker, a temporary outbox is created, the state machine is loaded from Mongo or found not to exist, it processes any messages are held in the outbox, it writes it to Mongo, Mongo write is successful, the outbox then goes and tries to send, and let's say RabbitMQ went down at that point. Well, if RabbitMQ can't send, MassTransit isn't going to acknowledge that message. And if the broker connection was dropped, MassTransit has no choice but to negatively acknowledge that message, which means RabbitMQ is going to redeliver that message. And so what's going to happen is it's going to say, okay, I have an allocation created message. I'm already in the allocated state. but I know that I didn't schedule that message. So what we're going to add here is a during allocated when allocation created, because that message is being delivered a second time for the same reason. We aren't going to transition, but we are going to schedule that message. Because if we don't schedule it, we don't know that it was ever scheduled. So hopefully that makes sense. It's a little hard to follow mentally with just by thinking about it. But the fact that that message could be redelivered after the transaction was committed means that we need to do the behavior, but not the state transitions that were part of that. So we'll put that in there. I don't think we'll hit that in our test case because I don't expect the broker to go down, and it's hard to get the timing right on that. Basically, you have to set a breakpoint, kill the broker, and then reproduce it, which is how I tested it. But yeah, so let's start up our service. We should know this build because solution-wide analysis says everything is good. Our warehouse is up and running. We will go create yet another order ID. Surprised nobody's like posted a curl script into the chat to do this automatically for me so I don't have to do it with the UI. That would be awesome. You can post it in Discord though, so it actually looks like code. Then I'm going to patch that in. And if I go look at my status, ooh, I got more errors. Awesome. What's this error? I got the requested, I got that. Allocation hold, created that. So the first process that came in, receive, transport, send. Where was my breakpoint? When did I restart the service? I restarted the service here because this is all the exchanges. The allocation created came out. I declared the exchange. I received the allocate inventory. The state machine allocate state was created. So it created two at the same time. Perfect. That's great. It called, oh, we got the exact same output. Why? Because defining a class doesn't actually put it anywhere. So this allocate state machine definition, I need to actually go and like use that versus just creating it. So here, where I'm in my add state machine definition, I need to pass in type of allocate state machine definition. Now, it would be great if it automatically discovered that from the container, but it doesn't in this case because I'm explicitly defining the Saga state machine. Because of the fact that you're configuring the repositories there, it's kind of hard to just say go discover everything and figure it all out. If you were just creating the MongoDB types in the container so that they automatically resolve for a state machine, you could have just said add Saga state machines from namespace containing and automatically added everything for you. I didn't do that in this example because I wanted to show that. So I have to pass that argument of that state machine definition type there. So now when I save that out and start it this time and go off and create another order ID and go off to here and post the order and go over to here and accept the order. And wait for it. What did I say it was? 15 seconds, 10 seconds? You can see that we did get the same issue. We got a warning this time because we retried and the Saga add failed, write operation and error, duplicate key error. But then we actually were able to go to the next one, and when we processed that allocation, you can see that the allocation was already released. So we did hit that logic where the allocation state machine, where's allocation already released? So we were in released when the allocation created landed because our routing slip had faulted and published that event. So we were able to just say, hey, I don't have to schedule anything. The allocation was already released. It's all good. We're done. So we know that we are able to handle that. We got the duplicate key error. It gave a warning because it was going to retry. You can see the R retry, and it shows which endpoint and which message it's going to retry. The warning outputs the error once. If my if my log level was error, I would have never seen that warning. It would have just disappeared. Yeah, so now my warehouse is up and running, but I want to make my service do something a little differently. So I'm going to kill this, and I'm going to go back to my payment activity, because the payment activity is failing so fast. It's like it's not even giving the allocation a chance to take hold. Now I think we set the hold time to like 15 seconds. So let's just do an await task.delay of like 5 seconds so that we give that other saga some time to run. So let's save that out. We'll run this version here. We'll go back in and generate the GUID. We will go back and do this dance again. This is the dance of my people right here. Patch, where's the patch? We will go out here. You can see that the routing slip took its time and then faulted. So if we go to the warehouse now, we can see that the warehouse, it created and added. So it created it, added it, put it in the correct state. Inventory was allocated. And the state machine ran. We scheduled the event. We allocated we removed the saga instance. We used that. We removed the saga instance. And then we just saw one more thing come through. We actually saw the allocation hold duration expired come through about 10 seconds later. Because we scheduled that message, but we didn't unschedule it when the allocation hold was removed. So the fact that we got rid of that allocation hold, we got a message, and I think by default the state machine is going to throw it away. I don't think it goes in skipped, but let's take a look. We have 3 messages in allocation state error. I wonder what they look like. Let's see what they are. One of them is a MongoDB write error because we didn't have the retry definition in there. One of them was the hold expiration received event is not handled in the release state, so that was one of them. And the other one was the same MongoDB error, so those aren't new. No worries there. We should probably purge those out. Don't need either of those. And allocation state error doesn't still have messages in it, does it? Okay, now it's closed. It just hadn't refreshed yet. So we know that this allocation hold duration expired message was sent towards the saga, but it was never, it didn't match to a saga, so I guess it didn't hurt anything. I mean, it just got processed and thrown away, and that's kind of the default behavior. You can tell it on missing instance to do different things, but I think we want to be a little more proactive in how we deal with that. So let's go ahead and stop that and go back to our allocation state machine. And let's say that we know that when we're in an allocated state, we have a scheduled message. And we know that's the case. So when when the expiration happens, we know the scheduled message was delivered, but here we know it wasn't. So we're going to add an unschedule and pass the name of the schedule. And what that will do is it will if the message is scheduled, it will send a message to the scheduling service to say, I no longer need this message, so don't send it to me again. Cool. So let's try that. We all know this song and dance by now. I'm going to go get a GUID. Over here. I'm going to create my order. Going to accept my order. Over here and watch my warehouse run. And so within 5 seconds, I should get the canceled because the payment's going to fail, which I just got. It removed the state machine instance. And you can see that we sent the cancel scheduled message to the Quartz endpoint. So if we go look at our scheduler, you can see that we received a cancel scheduled message, and we actually logged out that we canceled that scheduled message that was scheduled to happen at that certain point in time, which apparently it's almost 1 a.m. UTC. So most of Europe is probably asleep. I'm probably gonna have to do one of these at like 7 a.m. Fun, yeah. Be barely awake, drinking coffee the whole time. It'd be awesome. Yeah, so now we added the unschedule. So the things that we've covered in this session so far: routing slip activities that fail, showing that the compensations work, how to do unscheduling from a state machine. Trying to think what else there might be. What else is on my list? The other thing I had on my list was routing slip subscription sagas. So when we go back and look at that payment activity and that fulfill order consumer is going to execute the routing slip. And right now all we're doing is looking in the log to see what happened with it. It would be nice if the actual state machine, the accept order activity, which sent the accept order or sent the fulfill order command, was able to somehow notify the saga that the routing slip faulted and that the order is no longer in the accepted or canceled or submitted state, but that it was actually in the... I mean, we need to somehow know that the order failed and the order was not placed. So let me think about that. So we want to have a new state that, and I mean, we could go into a lot more process, because I mean, the order is still there, and it might, you know, we definitely want to retry that distributed transaction of allocating the inventory and processing the payment. It could be that our payment provider is down. So we could potentially create a state machine that would track just the routing slip and, you know, go by the tracking number, tie it back to the order ID. So then if we retried, we'd have the state of each one of those attempts. And that would be good for audit purposes, because we could look at like the payment activity and keep track of the authorization numbers and then the cancellations to the payment provider of those authorization numbers, so that if we need to do an audit of all the activity we do with our card processor at the end of the month, we would have that data. So I think that makes sense. I do think it would be cool just to add a simple event here that throws our order into a state so that we can go query it from the UI and see that it's in a problem state. So let's create a new state within the order here called faulted. Why not faulted? Faulted sounds like a good word. And we want a new event activity. Oh, look at this. We got, is that just generating a GUID? Because I can generate a GUID all day long. I want it to actually submit all the order and patch calls to the HTTP endpoint. I want the full ball of wax. I want a pipe delimited script, and I want the full ball of wax. Anyway, thanks, Drew. So how am I going to know it's faulted? I don't want to directly subscribe to the routing slip faulted event because I don't know the tracking number. And not knowing the tracking number, yeah, so Albert keeps pointing out, you can just type UUID in code, but I don't want to type it in my code. I just want it in my clipboard so I can go paste it into the UI. So yeah, you can just, Writer has so many like live shortcuts to where you can just say like UUID and hit tab. Wait, no, it didn't. Wrong. Mine doesn't do it. Mine doesn't do it, dude. I don't have the UUID shortcut snippet. That must be something magic. Anyway, back to the script, or we're off script at this point. So, oh, I see that it puts in the clipboard. I like the PB copy. That's legit. I totally get that. But now I want the curl commands. So the next thing, so we want that routing slip event, but we want our own event because we don't want to be subscribing to routing slip completed events within the Saga itself. That just feels weird, and because it's a generic It's a generic event. I mean, how do we necessarily know what ours? Plus the tracking number, how would we tie that back to our saga? Because we don't have a tracking number in our saga. Sorry about that. So what I think we want to do is we want to create a new message contract because I seem to love message contracts. So let's go over here to our contracts folder. And let's create a new one called order fulfillment faulted. That sounds great. Let's go with that one. And in here we will have, what are we going to have in here? We're going to have our order ID because we have to have our order ID. We have to know what's up with that. But what else do we want? Didn't we create a consumer that like subscribed to a bunch of these messages, our routing slip event consumer? So now that we have that, what all is in a routing slip completed event? Because if I've completed, there's some good stuff there. Do I really want that though? I really want to know the faults because the faults are what we're looking at right now. So what does routing slip faulted contain in it? Routing slip faulted has a tracking number, a timestamp, a duration, some exceptions. Exceptions might be cool. I don't really care though. I just want to go in the proper state. I don't think I need a reason to be there. I just want to go there. Oh, the timestamp would be useful to know. So what we'll do is we're going to create this order fulfillment faulted. We'll put the timestamp in there so that we get the time that it faulted. And then we're going to add this to our order state machine. So if you remember when we add an event, the first thing we have to do is come down in here and say order fulfillment faulted, and we will change this to fulfillment faulted. We're going to have to come in here, fulfillment faulted, correlate by order ID. Awesome. And what's going to happen is during, when do we send the activity to accept order, transition to accepted? So that's when we send it off for fulfillment. So we'll be in accepted. So let's say during accepted, although admittedly we'll probably end up with more. When the fulfillment faulted event occurs, we are going to, we're just going to transition to faulted at this point. There's no reason to write anything out. We're going to be able to query this from the UI. So when the fulfillment's faulted, we'll transition to faulted. Sounds good to me. I do think it would be cool to add some state, but I don't know what that state would be. Let's find out. Let's add a property. So we can query that out and get that in the result. We'll have to add it everywhere, but that's okay. Yeah, so let's just have a string fault reason. I don't think I have to do anything crazy because we're using Mongo, so it's just a new property. I don't have to remap it anywhere. And if the fulfillment faulted, I'm going to add a then. And what do I want to do? I want to say context.instance.fault reason equals. And I'm probably going to need something more in my event contract here. So if I go back to the fulfill order, nope, not that one. If I go back to the routing slip event activity consumer, did I even keep that around? Here's routing slip completed. I want routing slip faulted though. And I'm going to get these exceptions. I want to see what these exceptions work. So I'm going to try to get a nice little fault reason out of that. So I'm going to go ahead and add the activity exceptions here as well. Yeah. That's the fun, isn't it? My contracts currently don't have a reference to MassTransit, so adding the MassTransit types in there. Yeah, don't know if I like that. I think we'll go without the reason for now. And I'm not quite ready to accept a dependency on that, so we'll just be cool with it for now. So the fulfill order consumer, this is the one that's building the routing slip. And what I want to do now is I want to say, if this routing slip faults, tell this person over here that it faulted. In other words, I want to add a subscription to the routing slip so that it delivers a message to an endpoint if something bad happens. So what I'm going to do is I'm going to say builder.add subscription. I'm going to hope I remember how to do this. The address, I'm going to say context.source address, because I want to send it to the source address of the thing that told me to fulfill the order, which is a really cheating way to figure out how that came from, because I know the state machine sent it to me. The routing slip events that I want faulted events only. I want the routing slip faulted event. And for the event contents, I don't think I want any. So when I get the faulted, I can specify. So what I'm doing is I'm specifying a message type that I want the routing slip to send when it's completed. And I can tell it what event I want to use as the template for it, which in this case is the routing slip event faulted. And I can tell it what to include in that message. So if I don't want to include like data or arguments or the itinerary or any of the really heavy big stuff inside the routing slip, I can tell it not to include it. And so I think in this case, I'm just going to say none, because I don't want any of the big fluffy stuff. I'm not using it, so there isn't any reason to put it in the message. And then I am going to say send, the type that I want is order fulfillment faulted. And I'm going to initialize that type with fun order ID equals order ID. Context.message.order-id. So this is saying I want to subscribe to this. Oh, and I actually have to await this because I'm actually doing a delegate call to send that has to be awaited so that it can actually use the message initializer to create that message for you. So yeah, you have to await that. But fortunately, it told us we had to await it, so we didn't do anything silly. And then we build that. So what that's going to do is it's going to add a subscription. It's going to go back to the source of the fulfill order command, which is going to be the state machine. And it's going to say, if the routing slip faults, I want you to send an order fulfillment faulted message to that endpoint. So with that subscription added, and we've added to our state machine handling of that so that it will transition to the faulted state. Now we can go back to our service and restart our service with the new code in place. We don't need to touch the web. We haven't touched the web at all. We haven't modified anything in our website whatsoever. So we'll go to the website. We will start the process again. We will create our order. We will accept our order. We know that it's going to go off and do a bunch of things. In the meantime, we're going to come up here and we're going to get the status of our order. We can see that the status is faulted. So it went into the faulted state. And we can see that because we executed that, we allocated the inventory, we called the order state, and we can see that the contract we used an existing Saga instance. We used the sample contracts order fulfillment faulted message is what triggered it. It caused us to transition into the other state, and that's where that's at. And remember, because we did this and we set this up, and I guess it's still configured, switch to my other directory. So if we go into the Azure portal and we go into our application insights folder, we go into search, you can see we've been doing stuff all night, and because I've had this connected, we set this up and I never took it out, so all of this stuff has been being logged in Application Insights. I can actually go ahead and search. Let's just say within the last hour. Let's apply this to that. Let's see, that was 8:03. I would say that was the one we just did. I want to see how big this call stack is. Okay, so this was our inventory service. This is where we allocated the inventory. We sent the allocation created, the Saga repository loaded it. We know which Saga instance it was, what the initial state was. So it went to the allocated state, and then we received the allocate inventory compensate source address of the allocation release requested from the fault, which actually triggered it to release. And so we have the full call stack and call chain of that inventory being released from the routing slip. And if we come back in here, let's see, we should have one more refresh. Quartz allocation release requested, allocation state. Oh yeah, because we, oh right, because we actually inside here, because we received the allocation state, we went from allocated to final. Here is the cancel message. Here's where we actually sent cancel to Quartz to cancel the scheduled message. So we have that full end-to-end trace there. The one call I don't see in here yet, though, is the, and I'm hoping that it's there. You know, it has a lag of like 3 or 4 minutes. Still Quartz, so we'll wait for a second. Let's see, we have a question in the chat. Is this the new MT App Insights stack trace? It's fairly new. I think it came out with version 6, but since MassTransit now use diagnostic source internally for all activity tracing, everything is able to be output to Application Insights in real time. So you get full telemetry on all of your services, messages, connections. As you could see, the whole trace of, oh, now we got everything. Now we finally got a full report. So now you can see the whole report. So what you can see here is from the time I said order accepted, you have all of the call stack all the way down to the fulfill order. You have the execution of the routing slip. You have the execution of the allocation state. You have the handlers executed. You have the payment execute. You have the delay in the payment. You can see it's exactly the 5 seconds that we requested. You can see that it compensated the inventory allocation, and you can even see where it's sent to the order state. The allocate inventory compensate sent to that address, and the message type should be in here somewhere. Where's the message type? See the message type. Oh, because the order state receives it, and this is where it'll show that it was the order fulfillment faulted contract. So you'll see that it loaded that contract, processed it, and then the actual Saga started in the accepted state and went to the faulted state. So a question in the chat is, how does this work with Prometheus? I don't know. Alexei, one of the guys who works on some of the different MassTransit pieces, has contributed for a long time. He has a Prometheus listener for MassTransit, but it's built off the old middleware model, and it isn't looking at diagnostics trace. I don't know what it'll take to get that data writing out to Prometheus, but the intent, I think, would be to have a very similar way of writing the data. Now, this feels more like OpenTelemetry than Prometheus, so I could be wrong. This feels like Zipkin instead of Prometheus. Yeah, at least that's my theory, because Zipkin is more like end-to-end tracing, and I know OpenTelemetry is coming. But the intent is for that. So I mean, here you can see from the time I hit go on the patch HTTP endpoint, I have the absolutely everything that happened on the back end. And if you're in any sort of operation or SRE role or DevOps, this is invaluable. I mean, to have your engineers to be able to come back and say, oh yeah, there's the message ID, there's the tracking number of the routing slip, there's the activity type that ate it, there's the argument type that was passed to it. All of that data is there. And all the tags and everything are in there as well. So you can see all of that information if you pull the full data. I think there's a show all. I don't know how you see the tags in the UI or if they'll show them to you, but the tags are available for any of the diagnostic listeners. I mean, this is This is the butter right here. I mean, as far as I'm concerned, and App Insights is pretty reasonably priced. I mean, it's a PaaS service. You set it up, you set up your listeners, and you're good to go. So I'm glad there was a wow factor on that because this was fun to set up. And once I saw it, I was just like, these are cool screenshots. This is like the awesome. I mean, in 5.1 seconds for the activity because we put a sleep of 5 seconds in there. Oh, you're kidding, right? Does this work with 3.5.x? No, it works with 6. I would get on the latest. I would say at least 6.1, but yeah, there's no reason to go to 6.1 instead of going to 6.2.3. So we added a subscription to the routing slip. How about 2.1? Whatever. That doesn't even have Courier built in yet. That's like old school 2012 MassTransit, man. All right, well, that's most of what I wanted to cover tonight. I mean, we don't have to do the add a stock allocation thing at this point. I mean, I think we've covered enough for tonight, and we're getting into about an hour and 10 minutes, so it's probably a good time to take a break. I know that my voice is getting a little tired, but pretty good for a Tuesday night. I thought it was pretty interesting. Give me feedback on the session, content, things you want to see, requests. I did listen to the request of the people who said the font could be a little bigger, so I kicked it up a point. If the text is a little more legible, let me know. Let me know about the audio. I bought one of those fancy little mics, so I don't even know if you can see it, but it like glows red. It's really cool. But now that I've got like a cool podcaster mic, I'm like official or streamer mic, whatever. I don't know. It was very cool to do Best Buy curbside car delivery, no touch delivery. They like put it in your car without ever touching you or coming within 6 feet of you. It's pretty crazy the lengths we're going to stay in business with this stuff going on. But yeah, it was pretty cool. Yeah, and I mean there was a dozen cars parked out in front of the building, so it was great to see that they're still able to do business and fulfill orders given all the limitations. So thanks for joining. Good to have some people on the chat tonight. It's always more fun with friends, and I have several friends on the chat tonight, so that's cool. I'm glad you guys could make it out and see all the new stuff. You see, you guys need to upgrade, man. You gotta get off the old and busted and get onto the new hotness, man. All right, well, that's all I'm going to have for tonight. I'm going to sign off. Thanks, everyone, for joining, and we'll catch you on the next one.